x is equal to A inverse B. So A inverse is nothing but adjoint A divided by determinant A into B. So this is the adjoint of A. So writing rows into columns. So minus 1 minus 3 7, 3 1 minus 5, 5 7 minus 11. Minus of minus 1 becomes plus 1, plus 2, delete the column, delete the row, 2 2s are 4, minus into minus 3 becomes plus 3. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In the last session, we have learnt about the inverse of a matrix. Today, we are seeing one of the application of the inverse of a matrix, that is to find the unknown variables in a simultaneous linear equation. So here in this session, we are doing the matrix method to solve the system of linear equation. So previously, I have already taught to solve the linear equations using Kramer's rule. So this is also one of the method to find out the system of linear equation. So let me consider a linear equation in the form a1x, b1y, c1z is equal to d1. Similarly, a2x, b2y plus c2z is equal to d2. And a3x plus b3y plus c3z is equal to d3. So these are the three linear equation given. So here you can clearly say A, B, C are all the coefficients of the variable x, y, z, and D is the constant. Now how to solve the value or how to find the value of x, y, z from the method called the matrix method. So why it is called matrix method? Because we will write the coefficients of each variable here in the form of matrix A. So matrix A, so write all the coefficients in one matrix, that is A1, A2, A3, B1, B2, B3, C1, C2, C3. So this is one matrix and we will write the constant in another matrix called matrix B. So that is D1, D2 and D3. So after A, we will take one more matrix X where we will write only the variables used in a column matrix, that is X, Y, Z. Clearly when you say this, when you multiply AX, you will get the equation which you are observing on your left hand side. See, A1X plus B1Y plus C1Z. Next, A2X, B2Y, C2Z. A3X, B3Y, C3Z. So you will get the equations on your left hand side and the constant is taken as another matrix, that is D1, D2, D3. So clearly you can observe AX is equal to B. So this is in the form of AX is equal to B. But here I need to find out X. So to find out X, I will multiply A inverse on both sides. If you multiply A inverse on both sides, what happens for this equation here? A inverse into A into X is equal to A inverse B. So A inverse into A is nothing but I. Identity matrix with respect to any matrix is again X. So I into X is equal to A inverse B, or I get X is equal to A inverse B. So this is the formula to find out the values of X, Y, Z, that is by multiplying the inverse of matrix A to B, we can find X, Y, Z. And also inverse can be found using the formula adjoint A divided by determinant A into matrix B. So to find A inverse, we need to find out adjoint A as well as determinant A, unless and until determinant A cannot be equal to 0. So if A inverse exists, that means determinant A is non-singular. So first we will find out determinant A, then we will find out adjoint A, so that we can find out A inverse. Then we will multiply with the given B matrix to find the values of x, y and z. So this method of finding the solution for system of linear equation is nothing but the matrix method. So this is an important topic for 5 marks in your examination or 6 marks. So let's try to solve this using matrix method. First one, solve using matrix method. 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. So here it's a 2 cross 2 matrix. Whatever the concept we have applied for the previous 3 cross 3 matrix, the same thing we can apply here also. So first let us write the matrix. 5x plus 2y is equal to 4. 7x plus 3y is equal to 5. So now let's write the coefficients in one matrix, that is 5, 7, 2, 3. So this is our matrix A. And we will take x is equal to x and y because we have only two coefficients, and b is equal to 4, 5. So now I need to find out the value of the determinant. 5 3s are 15, 7 2s are 14, which is equal to 1. It is not equal to 0. Therefore, A inverse exists. Now, since A inverse exists here, next we need to find out A inverse. So, A inverse is nothing but adjoint A divided by determinant A. The value of the determinant is equal to 1. So therefore A inverse is nothing but the adjoint A only. Adjoint A is 3 minus 2 minus 7, 5. So divided by 1 we will get. So therefore A inverse is 3 minus 2 minus 7 and 5. Now we can find out x is equal to A inverse B. So what is x we have? X, y. What is A inverse? 3 minus 2 minus 7, 5. And B is 5 and 4. That is 4 and 5. So let's see now. First row, first column. 3 4s are 12. 5 2s are 10. Minus 10. Next, minus 7 4s are 28. Plus 5 5s are 25. We don't have another column, so we have only singular column. So therefore, xy is equal to here 2 minus 3. So clearly, we can write x is equal to 2 and y is equal to minus 3. When we say these two matrices are equal, if their corresponding elements are equal. So using that property, we can write x is equal to 2 and y is equal to minus 3. Next, solve using matrix method. X minus y plus 2z is equal to 3. 2x plus z is equal to 1. 3x plus 2y plus z is equal to 4. So here, let's write the coefficients in one matrix. So for the first one, it is 1, minus 1, 2. For the second one, it is 2. There is no y, so it is 0. Z, it is 1. Next, we have 3, 2, 1. So this is matrix A. Matrix X is X, Y, Z. Matrix B is the coefficients outside 3, 1, 4. So now we need to find out determinant of A. So let's see what is determinant of A. 1 into 0 minus 2. Minus, next we have minus 1. Remove the column and row here. So we have 2 minus 3. Next, plus 2. We have 2 2s are 4 minus 0. So we have minus 2 into 1 minus 2. Minus 1 minus 1 minus. We have 3 minus here. So it is minus again. So 1. Next, 2 4s are 8. So you will get determinant A is equal to 5, which is not equal to 0. So therefore, A inverse exists. So once A inverse exists, we need to find out adjoint A to find the A inverse. So let's find the adjoint A. So adjoint A is nothing but the transpose of the cofactor matrix, that is minus of each element. So first let us write minus of each element here. So now for 1, so it is plus we have, so it is 0 minus 2. Next we will see for minus 1, we have here minus outside. So we have 2 minus 3. Next plus, for 2, it is 2 2s are 4 minus 0. Let's find for 2. So for 2 it is minus 1 into 1. So minus outside. So it is minus 1 minus 4. Next plus. For 0 it is 1 ones are 1 minus 6. Next minus, for 1 delete row and column, 1 2s are 2 minus 3 becomes plus 3. Next for the 3, minus 1 minus 0. Next minus, for 2 it is 1 minus 4. Next for the last one we have 0 plus 2. So we need to take the transpose of this matrix. So first find out the values now. Adjoint, here minus 2, minus 1, plus 1 outside, 4. So minus 5 plus 5, minus 5. Next minus 5. Next is minus 1, minus 3, 3 and 2. So take the transpose of this matrix. So the transpose of this matrix is minus 2, 1, 4 and here you have 5, minus 5, minus 5, minus 1, 3, 2. So this is the adjoint A, the transpose of the cofactor matrix. Next, from the formula we have x is equal to A inverse B. So first let's write A inverse B. X is equal to A inverse B. So A inverse is nothing but adjoint A divided by determinant A into B. So let's keep the determinant A separately. What is determinant A value? We have 5. So let me write it in the form of 1 by 5 into what is adjoint of A? Minus 2, 5, minus 1, 1, minus 5, 3, 4, minus 5, 2 into. So this is 1 by det A, this is adjoint A and here we are writing B. So what is matrix B we have? We have 3, 1, 4. 3, 1, 4. So now x is equal to 1 by 5. Let us multiply here. So we will get only a column matrix because we are multiplying with the column matrix. Minus 2 into 3, 6. Plus 5 ones are 5, minus 4. Done. First row, first column, done. Next, second row, first column. 3 minus 5 plus 12. Next, 12 minus 5 plus 8. So we get x is equal to 1 by 5 into, here we get minus 5, 10 and 15. Now since we have 1 by 5 for the matrix, we can divide each value by 5. So on dividing, so x is nothing but x, y, z. And on the right hand side, divide each, here you will get minus 1, 2, 3. So comparing this, we can write x is equal to 1, y is equal to 2 and z is equal to 3. So this is the value of x, y and z. Next, so the same method, solve using matrix method. So let's write the matrix A, 1, 1, 1, 2, 1, minus 1, 2, minus 1, 1. So this is the matrix A. That is, write the coefficients of x, y, z from the 3 equation. X is nothing but x, y, z. And B is nothing but we have 5, 2, 2. 5, 2, 2. So after writing the matrix, our first aim to determine determinant A. So 1 into 1 ones are 1, minus 1. Next, minus 1, So 2 ones are 2, minus of minus 2 plus 2, plus 1, minus 2, minus 2. So this becomes 0, minus 4, and here minus 4. So determinant A is equal to minus 8, which is not equal to 0. So therefore A inverse exists. So once we got A inverse exists, our aim is to find out adjoint of a matrix. So adjoint is a transpose of a cofactor matrix. So let us write the coefficient. First let us write it in the form of plus minus plus minus plus minus plus minus plus. Because the minus is nothing but along with the sign it becomes a cofactor matrix. So now let's write the minors of each element. For 1 it is 1 minus 1. Next we have 2 plus 2. This we have already done here. Next minus 2 minus 2. Next let us take for 2. Delete column, delete row. 1 plus 1. Next 1 ones are 1 minus 2. Next for this it is minus 1 minus 2. For this minus 1 minus 1. Next for this column and row it is minus 1 minus 2. Next for the last element it is 1 minus 2. So we need to take transpose of this matrix. So first write adjoint A is equal to, so first one is 0, minus 4, minus 4. Next we have minus 2, minus 1, 3. Next minus 2, plus 3, minus 1. And the transpose of this matrix. So now let's take the transpose of this matrix. Adjoint A is equal to 0, minus 2, minus 2, minus 4, minus 1, 3, minus 4, 3, minus 1. So now this is our adjoint A. So after finding adjoint A, we have an equation x is equal to A inverse into B. So x can be written as adjoint A divided by determinant A into B. So let me write the determinant A separately. We have minus 8 as a determinant. So I'll write it in the form of 1 by determinant A can be written as minus 1 by 8. Now adjoint A. Let us write adjoint A. We have 0, minus 2, minus 2, minus 4, minus 1, 3, minus 4, 3, 3, minus 1. And we will write for B. So what are the values inside the B? 5, 2, 2. 5, 2, 2. Now x is equal to minus 1 by 8. Let us multiply. So we have 0, minus 2 2s are 4, minus 2 into 2, 4. Next minus 4 5s are minus 20, minus 2 plus 6. Next we have again minus 20 plus 6 minus 2. So here solving we will get minus 1 by 8 into, so we have minus 8. So minus 22 plus 6 is minus 16. Again minus 22 plus 6 minus 16. Since we have to divide this by minus 8, each element we have x as x, y, z. And now divide each element by minus 8, we get 1 and here it is 2, 2. So clearly we can write x is equal to 1, y is equal to 2 and z is equal to 2. Next question. Solve using matrix method. 3x plus y plus 2z is equal to 3. 2x minus 3y minus z is equal to minus 3. X plus 2y plus z is equal to 4. So let's write the factors or the elements. So 3, 1, 2, 2, minus 3, minus 1, 1, 2, 1. So this is our matrix A. X, Y, Z in matrix X and 3 minus 3, 4 in matrix B. Let us find the determinant A. So 3 into minus 3 minus 2 minus 1 into, we have 2 minus of minus 1 becomes plus 1 plus 2, delete the column, delete the row, 2 2s are 4, minus into minus 3 becomes plus 3. So here it becomes plus 2. So next we have 3 into minus 1 minus 3, next minus 3, next 4 plus 3 7, 7 2s are 14. So for 14 minus 6 you will get determinant A is equal to 8, which is not equal to 0. So therefore A inverse exists. So once A inverse exists, we will find out the adjoint A. So adjoint A is equal to the minors of all the elements. So plus, minus, plus, minus, plus, minus, plus, minus, plus, and the transpose of this matrix. So here, let us write the minors of each element. For 3 it is minus 3 plus 2. Next for 1 it is 2 plus 1. For 2 it is 4 plus 3. So from the determinant of the first row, you can see the minors of each first row element. Next we will go for the second row element. For 2 it is delete the column, delete the row, take the determinant of remaining element, that is 1 ones are 1 minus 4. Next 3 ones are 3 minus 2, 3 minus 2. Next take the determinant 3 1 1 2, 3 2s are 6 minus 1. Next we have take the determinant 1 2 minus 3 minus 1, that is minus 1, minus of minus 6 becomes plus 6. Next we have minus 3 minus 4. Next we have minus 9 minus 2. So let's solve this. Adjoint A is equal to, so we have minus 3 plus 2, which is minus 1. 2 plus 1 3 minus 3. 4 plus 3 7. Minus 3 minus 3. 1. 5 minus 5 becomes again 5. Next we have minus of minus 7 becomes plus 7 here. Minus 11. Transpose of this matrix. So let's write adjoint of A. So adjoint of A is minus 1 minus 3 7. Next we have 3 1 minus 5. Next we have 5 7 minus 11. So this is the adjoint of A. So writing rows into columns. So minus 1 minus 3 7, 3 1 minus 5, 5 7 minus 11. Now let's write A inverse. So we have x is equal to A inverse into B. X is equal to adjoint A divided by determinant A into B. Let's keep determinant A outside. We have determinant A is 8. So let me write it as 1 by 8 separately. Let's write adjoint A, that is minus 1 3 5 minus 3 1 7 7 minus 5 minus 11. On the other hand, that is the other matrix B is 3 minus 3 4. So 3 minus 3 4. Let's take the product of A inverse and B. So x is equal to 1 by 8. So we have here minus 1 minus 3 minus 9 plus 20. Next minus 9 minus 3 24. Next 21 plus 15 minus 44 plus 28. 7 4s are 28. Next 7 3s are 21. Minus into minus plus 15 minus 11 into 4 44. So therefore we get x is equal to 1 by 8. Here solving we get it as 12, 20, we get it as 8, and 28 minus 9 minus 3 is 16. Next 21 plus 15, 36 minus 44, we get it as minus 8. So now let's write the matrix X. It is X, Y, Z. So that is equal to 1 by 8 of each element. So if you take 8 by 8, it is 1, 16 by 8, it is 2, minus 8 by 8, it is minus 1. So hence we have two matrices equal. So therefore we can write x is equal to 1, y is equal to 2 and z is equal to minus 1. So this is how we will evaluate or find the value of x, y and z through the matrix method. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.